The theory that the universe may be a creation of an advanced civilization is known as the simulation hypothesis. This idea suggests that our reality is actually a computer simulation devised by a technologically advanced civilization. According to this theory, a sufficiently advanced civilization would be able to create a complex and realistic simulation in which conscious beings, such as ourselves, exist. This simulation could encompass the entire universe or just parts of it, and be designed to simulate the evolution of the cosmos, the formation of galaxies, stars, planets, and even life in different civilizations. Proponents of this theory argue that if human technology continues to advance, we will reach a point where we will be able to create simulations indistinguishable from reality. Therefore, it is plausible that a civilization even more advanced than ours has already reached this stage and has created one or several simulations. We are the Astrogeeks, your channel for astronomical curiosities and news. And to support us, don't forget to subscribe to the channel and leave that like to strengthen our community. So let's go to the video. The concept of the universe simulation is based on the idea that our reality is an artificial construct, similar to a computer simulation. According to this theory, we would be characters or programs, controlled by an advanced civilization that created this simulated universe. The simulation would be governed by rules and algorithms, allowing everything we experience and observe to be a virtual representation of reality. This hypothesis speculates that events, physical laws, and even human consciousness would be products of this fiction, challenging our traditional understanding of what is considered real. In 2003, philosopher Nick Bostrom of Oxford University in the UK formulated his hypothesis in this regard. He argues that, in fact, it is very likely that our universe is a simulation. This is because an advanced civilization must reach a point where its technology is so sophisticated that simulations cannot be distinguished from reality, and participants would not know that they are in fact in a simulation. This technology would allow them to create a virtual environment so detailed, complex and immersive that beings would have difficulty distinguishing between the simulated world and physical reality. This civilization would have mastered several areas, such as computing, artificial intelligence, large-scale data processing and modeling of complex systems. They would have deep knowledge of the fundamental laws of the universe and the ability to reproduce them accurately within the simulation. That's the idea that theoretical physicist John Wortball Weller had in 1989. Weller believed that the universe is essentially mathematical and can be seen as a result of information. One example is how quantum physics shows reality, which is much more complex and strange than we imagine, with particles that can be in two places at once and the influence of our observations on the behavior of these particles. Also, the nature of our own bodies suggests that we are just programs running on some kind of computer, and today we will explore these ideas in detail, looking at the evidence that supports this hypothesis and how researchers are preparing to run experiments that will ultimately confirm or refute this idea. Another curiosity in physics that supports the simulation hypothesis is the maximum speed limit in our universe, which is the speed of light. In a virtual reality, this limit would be equivalent to the maximum processing capacity of the system, that is, its processing power. We know that when a processor is overloaded, computer processing in a simulation slows down. Interestingly, Einstein's theory of general relativity also indicates that time slows down in the vicinity of a black hole. However, one of the most significant pieces of evidence comes from quantum mechanics, which reveals that nature is not really real. In this theory, particles do not appear to exist in specific states unless they are measured or observed. Instead, they exist in a combination of different states simultaneously, which resembles virtual reality, where the action depends on an observer or programmer. Another intriguing quantum phenomenon is entanglement, which occurs when two particles are connected in such a way that if you change one of them, the other will also be changed immediately, even if they are far apart. The most surprising thing is that these changes occur at speeds faster than light, which seems impossible. Although this simulation theory cannot be proven or disproven with 100% absolute certainty, it offers an interesting explanation for phenomena in quantum mechanics that would otherwise seem impossible. If we consider the possibility that we are inside a simulation, all locations would be equally distant from a central processor. While we may realize that particles are separated by millions of light years, this would not be true within the simulation. If the universe worked like a big video game, in which everything is created by a program, just like in a game, we could look for signs of information in the universe to try to prove that everything is a simulation. Just like in video games, where we find Easter eggs and hidden codes in different places, we could look for these clues in the universe to explore the idea that we are embedded in a simulation. Gathering concrete evidence on the simulation theory of the universe requires conducting careful experiments and observations. Although the idea of the simulation universe is fascinating, it is still considered a speculation and there is no direct evidence to support it. Therefore, it is essential to carry out scientific investigations to look for evidence that can support or refute this hypothesis. Experiments and observations allow scientists to test theories, obtain measurable data, and examine the workings of the universe for consistent patterns and behaviors. In this context, there are several approaches that can be taken. Computational modeling. Researchers can develop computational models to simulate virtual universes and compare them with our observable universe. These models can be used to explore the possible characteristics of a simulation and check whether they align with the laws of physics we know. Astronomical observation. Astronomers can carry out detailed observations of the cosmos, looking for anomalies, patterns or signatures that might suggest the presence of a simulation. This includes investigating complex structures, unexpected behaviors, or any hint of technological or programmatic limitations. Particle physics experiments. Conducting experiments in laboratories, such as particle accelerators, can help test the limits of known physical laws and explore possible inconsistencies or patterns that may be indicative of a simulation. Studies on the fundamental nature of reality. Research in areas such as quantum mechanics, string theory, and quantum gravity are relevant to examine the fundamental nature of reality and can provide clues about the existence or absence of a simulation. Importantly, regardless of the outcome of these investigations, the search for concrete evidence about the simulation of the universe is a constantly evolving scientific endeavor. Through rigorous experiments and observations, scientists seek to advance our knowledge and understanding of the cosmos, while also exploring the most intriguing questions about the nature of the reality in which we live. The definitive answer to the question, "Is the universe a simulation?" is yet to come. Do you believe this theory? What do you think about it? Let us know in the comments. Thank you for watching this far. I hope you enjoyed the video. If you enjoyed the content and want to continue exploring the fascinating world of astronomy, don't forget to subscribe to our channel so you don't miss any new videos. And also don't forget to leave your like, because it helps a lot in spreading our work. Share the video with your friends, so that everyone can embark on this cosmic journey with us. Together, we can take knowledge and admiration for the universe further and further.